Hi dear students, let's see this question that came in JEE Advanced Paper 1 Physics in the year 2021. The question is from the topic of EMI and this is slightly controversial in nature because of one assumption that's missing. So let's see what's happening over here. There's a long infinite wire which carries a current capital I in the shown direction and the value of I has been given as 2 ampere. We'll draw the figure along with. So basically, there's a long wire which carries current capital I. Okay. Now, parallel to this, there is an infinite rails which are having zero resistance, and there's a smooth semicircular wire that can slide on these rails. Okay, and this loop has been completed with the help of a resistor and a capacitor. The capacitance is 5 microfarad and the resistance is 1.4 ohms. At t equals to 0, the capacitor was uncharged. This distance has been given as 1 centimeter and this distance has been given as 4 centimeters. Now it's said that the wire starts moving, this semicircular wire starts moving at a speed of 3 meter per second. So we have to find the maximum current in the loop, that means maximum current in this circuit and the maximum charge on the capacitor. This is the question. Now let's first find the, suppose at any instant the velocity is v, किसी instant पे velocity v है. Okay, now this whole wire can be replaced by a straight wire for the purpose of EMF calculation. जितना EMF इसमें induce होगा, same EMF will be induced in this straight wire. How can we prove this? Consider this. इस semicircle में flux change नहीं हो रहा है because the total flux in this semicircle you can say is constant. The flux will be due to the magnetic field of this long wire. So total flux इसमें constant रहेगा, right? और जो EMF की जो पोलैरिटी रहेगी तो वो ऐसी रहेगी. This can be seen by the direction of v क्रॉस b. तो वेलोसिटी वेक्टर ऊपर है और मैग्नेटिक फील्ड स्क्रीन प्लेन के अंदर जा रहा है, तो v क्रॉस b अगर करेंगे तो पॉजिटिव पोलैरिटी विल बी लाइक दिस. Net EMF must be zero because flux is not changing, flux is constant. So net EMF must be zero. तो जितना EMF यहाँ इंड्यूस हुआ उतना EMF यहाँ इंड्यूस होगा. So this can be replaced by a single wire like this. तो इसको हम एक सिंगल वायर से रिप्लेस कर सकते हैं. ठीक है. Now let's consider a small element dx at a distance x. Let's write the EMF induced in this. Let's say the EMF induced in this is dE, which will be equals to BVL. B at this location due to this wire is mu naught I by 2 pi x. Velocity of this is v at any instant and the length is dx. So if you integrate this, so EMF induced will become mu naught I upon 2 pi v. Dx by x will become ln x, and x will vary from 1 centimeter to 4 centimeters. So this will become mu naught IV upon 2 pi ln of 4. ln 4 can be written as 2 ln 2. So that 2 and this 2 will be gone and this will become ln 2. This is the induced EMF. Now, the controversy is that if we assume V to be constant, which of course is not possible because there will be a magnetic force because of the current flowing in this loop, and that magnetic force will retard this wire. That means the velocity of this wire will decrease. So if we assume that to be true, then in this case the question will become unsolvable because we will require mass, data will become incomplete. See, in this case we have to find the maximum current and the maximum charge. Maximum current, that can be solved, but maximum charge we will not be able to find because we will require the value of the mass and also the differential equation, and the mathematics will become too difficult to handle. Also the data will become incomplete. So I believe that IIT will make this assumption that velocity supposedly should be constant. So anyway, so let's first find the value of I max. So maximum current will happen when the EMF is maximum, and the EMF is maximum when the velocity is maximum. So anyway, if velocity was changing also, then also for I maximum, we can say that will be equals to E upon R, correct? So that is mu naught I V ln2 upon pi into R. Okay. So even if V was changing, then also I max will not change. I max will be same. That means we can find the value of I max whether we take velocity to be changing with time or velocity to be constant. Although in reality velocity should change if there is no external agent. So just put the value of mu naught, which is 4 pi into 10 to the power minus 7. Value of I given in the question is 2 amperes. This I is the current flowing in the wire. Velocity at time 0 will be 3. ln2 is 0.7 given in the question. Divide by pi into resistance is 1.4. So 2 and 0.7 will become 1.4. This will get cancelled. Pi and pi cancel ho gaya. So this will become 1.2 into 10 to the power minus 6. And hence I max की value आती है 1.2 into 10 to the power minus 6. Okay. So as I said, अगर अपन velocity को change होता हुआ भी मानेंगे तो भी maximum current तो time 0 पे ही आ जाएगा. And at that instance velocity was 3 only. ठीक है. तो बेसिकली इस assumption से कि velocity is changing or not, I max को कोई फर्क नहीं पड़ने वाला. बट चार्ज के लिए इफ वी अज्यूम वेलोसिटी टू बी कांस्टेंट, तो फिर चार्ज तो फिर सिंपली सीई हो जाएगा. क्यू मैक्स की वैल्यू सीई हो जाएगी फॉर वेलोसिटी. अगर अपन वेलोसिटी को कांस्टेंट अज्यूम कर लेते हैं तो वी कैन से दैट कि एक आरसी सर्किट में कन्वर्ट हो जाएगा जहां पे ईएमएफ की वैल्यू कांस्टेंट है बिकॉज वेलोसिटी इज कांस्टेंट. तो फिर चार्ज को अपन सी लिख सकते हैं. कैपेसिटेंस इज 5 into 10 to the power minus 6. ठीक है. ईएमएफ की वैल्यू वापस यहाँ से डाल सकते हैं. ठीक है. तो म्यू नॉट, और तुम या फिर ईएमएफ की वैल्यू ये 1 आई मैक्स इंटू आर लिख सकते हो सीधा. ठीक है. ईएमएफ की वैल्यू यहाँ से आई मैक्स इंटू आर लिख सकते हैं. तो आई मैक्स कितना आया था 1.2 इंटू 10 टू द पावर माइनस 6 और आर कितना आया था 1.4. ठीक है. तो ये सॉल्व करने से कितना 12 5 जा 60 एंड 46 जा 84. तो ये हो रहा है 8.4. ठीक है. इंटू 10 टू द पावर माइनस 12, राइट. So Q max becomes 8.4 into 10 power minus 4 coulombs. Again, this is correct only if we assume velocity to be constant, which in my opinion is not the reasonable assumption to make. But if we uh, actually try to capture the variable nature of velocity, then as I told you, the data will become incomplete. So in my opinion, IIT will consider A and C as the correct answer. However, they might go with only A as correct also if there are enough challenges that are raised. But I have that hunch, I have that, like my sixth sense is saying that IIT will be taking A and C both as correct, or they might also give release to answer keys both AC correct or single A correct as well. But I have strong feeling that they will be going with A and C. That's what I feel. Although I have told you that in reality velocity will change, and that will make the value of Q max like option C wrong, because we will not be able to find the value of Q max, because for finding Q max the value of mass should have been given in the question. So that's it. I hope you would have understood. Thank you.